Introduction. Ajay, what are you reading? I'm reading my chemistry textbook. Arjun, don't put that pencil into switch. You will get the electric shock. Electric shock? But why? Pencil is made up of wood and graphite, and both are non-conductor of electricity. Arjun, you must know that graphite is a non-metal, but it is a good conductor of electricity. I don't have any idea about that. Okay, I will show you with the help of an experiment. When we on the circuit, then multimeter shows an electric current reading. It shows that graphite allows the electric current to pass through it. Hence, graphite is a good conductor. Ajay, now I understand the point. And I want to know more about this. Graphite is an allotrope of carbon. Carbon is one element from the p block of periodic table. To understand more about this, first we have to study the p block elements. Students, today we will study about the p block elements. Objectives. At the end of this lesson, you will be able to define p block elements, define inert pair effect, understand group 13 elements, analyze physical and chemical properties of group 13 elements, explain
anomalous
properties of boron, analyze compounds of boron, understand group 14 elements, explain general characteristics of group 14 elements, analyze physical and chemical properties of group 14 elements, know about allotropes of carbon, analyze some important compounds of carbon and silicon. Definition. Elements of group 13 to 18 of the periodic table are collectively called p block elements. Boron, carbon, nitrogen, oxygen, fluorine and helium head the groups. The general electronic configuration of these elements is ns2np126. They involve the filling of p orbitals of their outermost shell. The maximum oxidation state shown by a p block element is equal to the total number of valence electrons. This maximum oxidation state is called the group oxidation state. Inert pair effect. The term inert pair was first proposed by Neville Sidgwick. The inert pair effect is the tendency of the outermost s electrons to remain unionized or unshared in compounds of post-transition metals. The term inert pair effect is often used in relation to the increasing stability of oxidation states that are 2 less than the group valency for the heavier elements of groups 13, 14, 15 and 16. Group 13 elements. The boron family. Boron family shows a wide variation in properties. Boron is a typical non-metal. Aluminium is a metal but shows many chemical similarities to boron. Gallium, indium and thallium are almost exclusively metallic in character. Electronic configuration. The outer electronic configuration of group 13 elements is ns2np1. Boron and aluminium have noble gas core. Gallium and indium have noble gas plus 10d electrons. Thallium has noble gas plus 14f electrons plus 10d electrons cores. Atomic radii. On moving down the group, the atomic radii increases. However, atomic radius of gallium 135 picometer is less than that of aluminium 143 picometer. It is because the presence of additional 10d electrons offer poor screening effect for the outer electrons from the increased nuclear charge in gallium. Ionization enthalpy. Its value does not decreases smoothly down the group. The decrease from boron to aluminium is associated with increase in size. The increase from aluminium to gallium is due to discontinuity in the ionization enthalpy. The increase from indium to thallium is due to inability of d and f electrons, which have low screening effect. Physical properties of group 13 elements. Boiling point of the elements decreases down the group. Density of the elements increases down the group. Melting point of the elements first decreases and then increases down the group. Boron has highest electronegativity. from aluminium to thallium, electronegativity increases. Boron is a non-metal, whereas aluminium, gallium, indium, thallium are metals. Chemical properties of group 13 elements. Reactivity towards air. Boron does not react with air in crystalline form. Aluminium forms a very thin oxide layer on the surface which protects the metal from the further attack. Amorphous boron and aluminium metal on heating in air form B2O3 and Al2O3. With dinitrogen at high temperature, they form nitrides. Reactivity towards acids and alkalines. Boron is unreactive with acids and alkalis even at moderate temperature. Aluminium shows amphoteric character and dissolves in mineral acids and aqueous alkalis. Aluminium dissolves in dilute HCl and produces dihydrogen. Reactivity toward halogen. Boron family elements react with halogens to form trihalides.
Anomalous.
Properties of boron. Boron is a non-metal having some metallic properties. It has electropositive character. Boron forms trivalent compounds. It liberates hydrogen on boiling with NaOH solution. Binary compounds of boron are known as borides. Boron trifluorides easily react with Lewis bases such as NH3 to complete octet around boron. Some important compounds of boron. Borax. It is also called sodium tetraborate decahydrate. It has been found that crystalline borax contains tetranuclear units of B4O5OH4 whole 2 negative. Hence, its formula is given by Na2B4O5OH4 into 8H2O. Crystalline borax is sparingly soluble